Hello, today we're going to go over maybe a three-part little mini-series on what I've done wrong again for some of the work I've done in the past. So this is going to be the TPS22916. I believe this was a load switch. I've been asked to make a simple breakout board and provide the schematic and the details of bill of materials and the PCB for it. So I have the part right here, simple load switch output discharge by TI. Here is the data sheet for it, as I followed the simple schematic here, I believe, into what was recommended, layout guidelines also, which I'll get into. And as you can see, it is a bit messy, but let's get into it. So when I started off with this project, I looked at the data sheet. The client asked me to build a breakout board out of this, and I happily agreed to it. I've done breakout boards in the past for microcontrollers and everything. So I looked into it, see what it did, and looked at the description because I like to know what I'm working with. And it looks like it's a single channel load switch, low P channel MOSFET for minimum power loss. So I suppose this might be, I could be wrong here. You could use MOSFETs as a switch, but I suppose this provides lower leakage compared to a FET. Not too sure on that one. While a MOSFET can be used to achieve the same purpose as a load switch does, you may be wondering what is the exact difference in between the two. Shouldn't I just use a FET? It's what I'm comfortable with. Well, compared to a load switch, in this case, you do not have the benefits of it, such as no inrush current control. They may have like a power good output or some thermal shutdown feature, something of that sort, which makes your circuit a bit more robust, and you could do a lot more things with it. You can still achieve the same effect with a FET, but you just have a bit more components onto it, which this means your cost increases, this means your complexity increases, and as well the size of your circuit. So why put in any of that when a load switch can achieve just that? And this is why someone might use a load switch over just a simple FET. As I've said before, I've put in an article by TI in which they go into why you would use an integrated load switch versus discrete MOSFETs. Do have a read through it to understand a bit more. But it was a switch nonetheless, from what I gathered. And so afterwards I went to the datasheet to look at it and what's its details for it. Read the description, look at the simplified schematic, thought, okay, so it's got a V and V out ground and an on-off switch whether the load wants to be turned. So it's a BGA package. So it looks to be a ball grid package. Scrolling down, we see a test circuit, we see the detailed description of what it is, a block diagram on how it works. It's all interesting stuff. And what we're looking for here is the typical application probably would have helped in this case, and this is the layout guidelines. We're creating a breakout board for it. So as you can see, it says a ground via bypass capacitor. This was the GPIO control, ground, and a V in V out switch. So it's fairly simple, not much to do. Let's take a look at the board. The schematic itself, again, very simple. Nothing much to go about it, but as you could see, I didn't make these parts myself. So this is why the grid itself is messed up. Now, I've always said make your own component, and it's for this reason. So I could have realigned it really, and it was really very amateurish on my part, and it's something I would not want to do again. So this could be put here, and this could be switched really for ease sake. I mean, it's really, no one reads the V out. For fear V out supposed to be on here, really I could put the on there, but I just took this part as it came, I believe. And looking at this now, as you can see, I've got the V out and VDD and the VDD here. So I don't have a line for V in, but I use VDD as my V out, and this might have been confusing if now that I looked at it, because I've just got a bit confused here. I was done like, oh, why is it this? Maybe I should have labeled it as V out actually and put the net labels on there that came to the board itself. So this one was also permanently tied to ground. Let's look at the data sheet for why I did that. And if I looked at this, I just said I just looked at the data sheet. I should have included a note here on what this on was, and this is why you should include notes in your schematics for why it should be. Certain parts, when you come back to it, read it again, and you're wondering, oh, why is this here? I don't really understand. Back at the data sheet here, we're trying to look for the on and off. And to find this, it will be usually in the pin configuration. So I've had a read through it, and I've had a read through, and this is just a standard up. So high, low, high would be on, low is turned off, and on over here it looks like I've labeled this down to ground, which should be, well, this device is always off. Coming into here, I select here, B1 is ground. Well, this is not connected to ground, this is connected to 4. 4 is connected to ground, and this doesn't seem to be the case. So what actually is going on here is that I've mislabeled it at that point of time in which V in was correct, and it's actually B2, in which if we look back at the schematic, we can see that it was actually connected to ground. B1 was ground, and this should have been labeled ground as opposed to on. So these two were necessarily switched, but because this was always labeled to the PCB header, it was correct at the time. So it was still usable, the switch, although the schematic said otherwise. So this is must have what happened during when I designed the PCB, which is very poor and amateurish layout, and let's just say it's very disgusting behavior, really, and should have never been done, should have been double checked. And before, it's just probably a stroke of good luck that it still worked, and the package was quite simple. It was only 4 pins. So I'm wondering, this is probably different, and this is probably what led to a very amateurish move of that I've changed the PCB without changing the schematic. So this is wrong entirely and will need to be adjusted, which I will do in my own time. I think maybe I do not have the right, and looking at this now, that this is very, very wrong and should have not been released, really. If this was an actual thing, the note should be here to why this component, what this component does, why is this connected to ground, because I've had an issue looking at it. There should be net ties, so these net labels here, where they place string text, parameter place net labels, so this should be a net label here. So really this should have just been V out, something like that, placed it along here. V in should have been placed like that, so when it came to routing, this would have been correct, this should have appeared, so it appears VDD now, but when it comes to V out here, this would have been labeled V out. Now coming along to the layout itself, this bar all of my mistakes, I've put the silk screen on the other side, it seems. Layers this text, bottom overlay. In reality, we could just place it here, not sure why I placed it down there, and this would have been much more suitable. I could have also placed the silk screen along here for the connector itself to know the component outline, which is always helpful. Now back to the, if we go back to the PDF here, to the layout guide, I've always said before, this is why you follow the layout guide. It tells you it's got a pore here. Over here I've essentially just tried to squish it in, and it will work, but you would want a pore because it is a load switch. I do not know what the client in mind had to transfer this, but I've tried to reduce it amount by using various things to go almost like teardropped it. So if I press it, so this is kind of like teardrop, tools, teardrop. So I've kind of done it like this, and this is the tool I've used it to adjust it to make it easier entrance for, you know, to make it easier for power to go through here. And really I could have just done a polygon pore. If I move this down, put a polygon pore here, and that would have been more suitable. I've got the name there, which is alright, but really this is the main concern with the, this is the main concern here. I should have done a polygon pore at the time. As well added a silk screen here for the component outline, which is no issue. As you can see, I've got the pin 1 marking, which is fine. There should have been component outline for the part itself because the user won't know. I wouldn't know. If we go to the 3D view here, you could see the 3D view of the model. So this one was pretty simple to go off of, but there was quite a bit of learning in itself. There's quite a bit of learning in itself, and it's always notable to really check your work and to make sure to add notes required in it. I've got a few more boards I'm going to go over for you in separate videos, but that was one I would like to share. And hopefully you don't do or make the same mistake as I've done.